Hello, in this lecture we will find out the length of line segment MN. In the drawing we have square ABCD. We know that one side of square ABCD is equal to 12 units, that is to say AB equals to BC equals to CD equals to DA equals to 12 units. And inside this square ABCD we have a circle. The center of this circle is at point M, and we also have a semicircle, and the center of this semicircle is at point N. And we want to find out the distance between the centers of the circle and the semicircle, that is to say the length of line segment MN. Okay, so first of all we will define the point of tendency of tangent AB with this circle as point P. We will define the point of tendency of tangent BC with this circle as point Q. We will define the point of tendency of tangent AC with this circle as point R. We define the point of tendency of tangent AC with this semicircle as point S, and we define the touching point of the touching point of the semicircle with side DC as point T, and we'll also define the length of line segment PB as A, and we actually know that AB is equal to 12 units and PB equals to A units according to our definition. Therefore, line segment AP will be equal to AB, that is 12 units, minus PB, that is A. That is to say, AP will be equal to 12 minus A units. In the next step, I will present to you a new rule. That will be rule number 1. According to rule number 1, the lengths of two tangents from a common external point to a circle are equal. I will read rule number 1 again. According to rule number 1, the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 1? The meaning of rule number 1 is that if we have an external point, this point is point P, and point P is an external point in relation to this circle. Why point P is an external point in relation to this circle? Because of the fact that point P is not located inside this circle nor on this circle, but it is located outside of this circle. Therefore, point P is defined as an external point of this circle. So if from the external point P we draw two tangents to this circle, so the first tangent will be this tangent, we'll define the touching point of the first tangent with this circle as point A, and we'll also draw a second tangent to this circle. This is the second tangent. We'll define the touching point of the second tangent with this circle as point B, the point of tendency. So according to rule number 1, the lengths of two tangents, that is to say the length of the first tangent is PA and the length of the second tangent is PB. And according to rule number 1, the lengths of two tangents from a common external point, that is to say from the common external point to a circle, to points A and B, are equal. That is to say, PA, the length of the first tangent, that is PA, must be equal to the length of the second tangent, that is PB. That is to say, PA is equal to PB. So whenever you draw two tangents to a circle from a common external point to that circle, then the lengths of those two tangents will be equal to each other. In this case, PA will be equal to PB. Okay? So we actually can implement rule number 1 in our drawing, because in our drawing we have the external point B. From the external point B, we have two tangents to this circle. The first tangent is tangent BP. The second tangent from point B, from the external point B, is BQ. And according to rule number 1, the lengths of those two tangents are equal to each other. That is to say, BP is equal to BQ according to rule number 1. But according to our definition, BP is equal to A. So we can write here that BP equals to A. And from this equation, A equals to BP equals to BQ, we will derive that BQ is also equals to A. BQ is also equals to A, so we can write here that BQ is equal to A in its length. So if BQ equals to A and BC equals to 12, then QC will be equal to BC, that is 12 units, minus BQ, that is A. In conclusion, QC will be equal to 12 minus A, exactly like the length of AP, that is also 12 minus A. Okay? So we will focus on the external point A. From the external point A, we have two tangents to this circle. The first tangent is tangent AP. And the second tangent from the external point A is AR. And according to rule number 1, AP is equal to AR. But according to what we have already found out, AP equals to 12 minus A. AP equals to 12 minus A. From this equation, 12 minus A equals to AP equals to AR, we will derive that AR is also equal to 12 minus A. Okay, AR is equal to 12 minus A, so we can write here that AR equals to 12 minus A units. We will continue to focus on the external point A. From the external point A, we have we have two tangents to the semicircle. The first tangent is tangent AD, and the second tangent is tangent AS. And according to rule number 1, they must be equal to each other. I repeat again. According to rule number 1, the lengths of those two tangents are equal to each other. That is to say, AD is equal to AS. Here AD, the point of tendency here is at point D, must be equal to AS. Here the point of tendency with the semicircle is at point S. So according to rule number 1, AD equals to AS. But we know that AD equals to 12 units. This is one side of the square, that is to say it equals to 12 units. And from this equation, 12 equals to AD equals to AS, we will conclude that AS is also equals to 12 units. So we can write here that AS is equal to 12 units. So here, what is the value of line segment RS? From the drawing, it is very easy to see that the value of the length of line segment RS it is actually equals to AS minus AR. Again, RS equals to AS minus AR. So actually, RS is equal to AS, that is 12, minus AR. We already found out that AR equals to 12 minus A. So minus 12 minus A. So we actually found out that RS is equal to 12. We will open the brackets here. 12 minus 12, minus and minus is plus, so it is plus A. 12 minus 12 is 0, so in conclusion, we found out that RS is equal to A. RS is equal to A. So here we found out that RS is equal to A units. And we will focus, in the next step, we will focus on the external point C. From the external point C, we have two tangents to this circle. The first tangent is tangent CQ, and the second tangent from the external point C is tangent CR. And according to rule number 1, the lengths of those two tangents are equal to each other. That is to say, CQ is equal to CR according to rule number 1. But we have already found out that CQ equals to 12 minus A. So from this equation, 12 minus A equals to CQ equals equals to CR, we will derive that CR is also equals to 12 minus A. CR is also equals to 12 minus A. So we can write down that CR is also equals to 12 minus A. So if CR is equal to 12 minus A, then what will be the length of line segment SC? The length of line segment SC will be equal to RC minus RS. I'll repeat again. The length of line segment SC will be equal to RC minus RS. So SC is equal to RC, that is 12 minus A, minus RS, that is A. So in conclusion, we found out that SC is equal to 12 minus A. So SC will be equal to 12 minus 2A. So we found out that SC is equal to 12 minus 2A. So we can write here that SC is equal to 12 minus 2A. And what is the value of diagonal AC? The length of diagonal AC. From the drawing, it is very easy to see that the length of diagonal AC is equal to AR plus RC. So here AC equals to AR, that is 12 minus A, and RC is also equals to 12 minus A. So in conclusion, AC equals to 12 minus A plus 12 minus A. 12 minus A plus 12 minus A is 12 plus 12 is 24. Minus A plus minus A is minus 2A. So in conclusion, we found out that AC equals to 24 minus 2A. AC equals to 24 minus 2A. Diagonal AC equals to 24 minus 2A. In the next step, I will present to you a new rule. It will be rule number 2. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So I will read rule number 2 again. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So what is the meaning of rule number 2? The meaning of rule number 2 is that if we have this circle and we know that the center of this circle is at this point, point O, and we also have tangent AB to this circle, here tangent AB, this tangent is tangent to this circle at this point. This is the point of tendency. We'll define the point of tendency as point M. M is the point of tendency of tangent AB with this circle. Point of tendency. We'll join points O and M together by a straight line. Here, OM is the radius of this circle because of the fact that it starts from the center of this circle, that is to say from point O, and ends at point M, that is a point on this circle itself. Therefore, OM is the radius of this circle. We'll define the radius of this circle as R, abbreviation for radius. So here we have the radius of this circle, that is to say OM. It is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to that radius. In this case, the tangent AB will be perpendicular to the radius MO. So AB is perpendicular to MO, that is to say this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Okay, so whenever you have a tangent that is a radius that is perpendicular, whenever you have a radius that is drawn to the point of tendency, then tangent will be perpendicular to that radius. In this case, tangent AB will be perpendicular to the radius MO, that is to say this angle equals to 90 degrees and this angle also will be equal to 90 degrees. Okay, so we can implement rule number 2 in our drawing. Here we join points M and P together by a straight line. Line segment PM is the radius of this circle because of the fact that it starts from the center of this circle, that is to say from point M, and then at point B, that is the point of this circle itself. Therefore, PM is the radius of this circle. So the radius PM or MP, it is drawn to the point of tendency, that is to say it is drawn to point P, that is the point of tendency of tangent AB with this circle, and whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to that radius. In this case, tangent AB will be perpendicular to the radius PM. AB perpendicular to PM, that is to say this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. And we also know that all the four angles inside a square are right angles, therefore angle ABC, that is one out of four angles of square ABCD, must be equal to 90 degrees. In the next step, we will join points M and Q put together by a straight line. Here MQ is the radius of this circle because of the fact that it starts from the center of this circle, that is to say from point M, and ends at point Q, that is the point of this circle itself. Therefore, MQ is the radius of this circle. And we have the radius MQ that is drawn to the point of tendency, that is to say it is drawn to point Q, that is the point of tangency of tangent BC with this circle. And whenever you have a radius that is 1 to the point of tangent, whenever you have a radius that is 1 to the point of tangency, then the tangent will be perpendicular to that radius. In this case, tangent BC will be perpendicular to the radius QM. So BC is perpendicular to QM, that is to say, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. So actually, in quadrilateral PBMQ, in quadrilateral PBMQ, we have 1, 2, 3 right angles. The sum of 3 right angles is 90 times 3 is 270 degrees. Plus the size of the fourth angle, that is actually angle PMQ, this angle. In total, the sum of those 4 angles, it must be equal in total to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. We subtract 270 degrees from this equation and we get that angle PMQ, the missing angle, it is equal to 360 degrees minus 270 degrees, it is 90 degrees. So we found out that angle PMQ is a right angle. So here, angle PMQ is a right angle. So actually, quadrilateral PBMQ has 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle. So we can write down that quadrilateral PBMQ that has 4 right angles must be at least a rectangle, if not a square. Okay, quadrilateral PBMQ that has 4 right angles must be at least a rectangle. And we have rule number 3. According to rule number 3, the opposite sides of a rectangle are equal to each other. I will read rule number 3 again. According to rule number 3, the opposite sides of a rectangle are equal to each other. So in rectangle PBMQ, PB must be equal to MQ according to rule number 3. Again, PB must be equal to MQ according to rule number 3. Rectangle PBMQ. But according to our definition, PB equals to A. So for this equation A equals to PB equals to MQ, we will derive that MQ is also equals to A. So we found out that AQ equals to A. Likewise, according to rule number 3, BQ must be equal to PM. Rule number 3. But we've already found out that BQ equals to A, so from this equation A equals to BQ equals to PM, we derive that PM is also equals to A. PM is also equals to A. So from a negative that PM equals to A, we actually found out that quadrilateral PBMQ is not a rectangle but a square. Okay, in the next step we will implement the Pythagoras theorem on the right triangle, triangle ABC. Right triangle, triangle ABC. According to PT, that is abbreviation for Pythagoras theorem. We get that the square of the hypotenuse is AC squared. So the square of the hypotenuse is AC squared, and it must be equal to the sum of the squares for the perpendiculars. That is to say, it must be equal to AB squared plus BC squared. I'll repeat again. In the right triangle, triangle ABC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AC squared equals to AB squared plus BC squared. And we have already found out that AC equals to 24 minus 2A. Therefore, AC squared will be equal to 24 minus 2A squared. And it equals to AB squared, that is 12 squared, plus BC squared, that is also 12 squared. So here, according to question number 2, (24 minus 2A squared) equals to 12 squared plus 12 squared is 2 times 12 squared. So, according to equation number 2, 24 minus 2A equals to 2 times 12 squared. Here we will take a root out of this equation, and we'll get that So according to equation number 2, 24 minus 2a squared equals to 2 times 12 squared. We take out from this equation number 2, and we get that 24 so we took out of this equation number 2, and we got that according to equation number 2, 24 minus 2a equals to the square root of 2 times 12. Why the square root of 2, the square root of 12 squared is 12? Because of the fact that the root cancels the square and we left only with the 12. So according to equation number 2, 24 minus 2a equals to square root of 2 times 12. Here we will add to this equation 2a, and then we will subtract, we'll add 2a, and we'll subtract square root of 2 times 12 units, and we get that according to equation number 2, 2a equals to 24 minus square root of 2 times 12. So we found out that 2a equals to 24 minus square root of 2 times 12. And we divide equation number 2 by 2. Again, 2a, according to equation number 2, equals to 24 minus 12 times square root of 2. So, found out that according to equation number 2, 2a equals to 24 minus 12 times square root of 2. We divide equation number 2 by 2, and we get that according to equation number 2, a equals to 24 over 2 is 12, and minus 12 over 2 is minus 6. So it is minus 6 times square root of 2. So finally we found out that a equals to 12 minus 6 times square root of 2. So 8, it is the radius of the circle, equals to 12 minus 6 times square root of 2 units. In the next step, we will define the radius of the semicircle as b. Here dn, line segment dn is the radius of the semicircle because of the fact that it starts from the center of the semicircle, that is to say from point N, and ends at point O, that is a point on the semicircle itself. Therefore, dn is the radius of the semicircle, that is to say it equals to b units. Likewise, nt is also the radius of this circle because of the fact that it starts from the center of the circle and ends at point E, that is a point on the semicircle itself. Therefore, nt is the radius of the semicircle, that is to say it is also equals to b units. And what is the value of Tc? Here, from the drawing, it is very easy to see that Tc equals to dc minus dn minus nt. I will repeat again. Tc equals to dc minus dn minus nt. So Tc is equal to dc, that is 12 units, minus dn, that is b, minus nt, that is also b. So in conclusion, we found out that Tc is equal to 12 minus b, that is to say it equals to 12 minus 2b. Okay, is equal to 12 minus 2b. So you can write here that Tc is equal to 12 minus 2b. In the next step, we will join points N and S together by a straight line. Here, line segment NS is the radius of this semicircle because of the fact that it starts from the center of this semicircle and ends at point S, that is a point of this semicircle itself. Therefore, NS is the radius of this semicircle, that is to say it equals to b units. And the radius NS of the semicircle, it is round to the point of tendency, that is to say it is round to point S, that is the point of tendency of tangent AC with this circle, and whenever you have a radius that is round to the point of tendency, then the tangent will be perpendicular to that radius. In this case, AC will be perpendicular to SN. AC perpendicular to SN, that is to say this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. Okay. And because of the fact that we found out that angle NSC is a right angle, therefore the green triangle NSC is a right triangle, so we can implement the Pythagoras theorem on the green right triangle NSC. So in the green right triangle NSC, according to the Pythagoras theorem, I repeat again. In the right grade triangle NSC, according to the Pythagoras theorem, this will be equation number 2. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is NC, so what is the length of NC? The length of NC is actually equals to NT plus TC. So NC equals to NT that is B plus TC that is 12 minus 2B. So NC equals to NT plus TC, so NT equals to B and TC equals to 12 minus 2B. In conclusion, we found out that NC, the hypotenuse of the green right triangle NC is equal to 12, B minus 2B is minus B, so it is 12 minus B. NC equals to 12 minus B. We can only tell that NC equals to 12 minus B. NC equals to 12 minus B. Now we will implement the Pythagoras theorem on the right green triangle NC. According to the Pythagoras theorem, this will be question number 2. The square of the hypotenuse in the right green triangle NC, the square of the hypotenuse must be equal to the sum of the squares of the perpendiculars, that is to say, NC square must be equal to NS square plus SC square. So we know that SC equals to 12 minus B, so SC square will be equal to 12 minus B square. So according to equation number 2, NC square equals to NS square plus SC square. We have already found out that NC equals to 12 minus B, so NC square will be equal to 12 minus B square. And it equals to NS square. NS is equal to B, so NS square will be equal to B square plus SC square. SC square equals to 12 minus 2A square. So we found out that according to equation number 2, 12 minus B square equals to B square plus 12 minus 2A square. We will find out the value of the expression 12 minus 2A. So the value of that expression 12 minus 2A will be equal to 12 minus 2 times A, and A equals to 12 minus 6 times square root of 2. So we have 12 minus 2 times 12 is minus 24, minus 2 times minus 6 is plus 24. So 12 minus 2A equals to 12 minus 2 times a, and a is equal to 12 minus 6 times root of 2. So we have 12 minus 2 times 12 is minus 24. Minus 2 times minus 6 is plus 12. And here we have also square root of 2. So we have here 12 times square root of 2, and 12 minus 24 is minus 12. So in conclusion, we found out that 12 minus 2a is equal to 12 times root of 2 minus 12. Here we take 12 as a common factor, and we get that 12 minus 2a is equal to 12. Inside the brackets we have square root of 2 minus 1. So 12 minus 2a, after we took 12 as a common factor, inside the brackets we will have square root of 2 minus 1. So in conclusion, we found out that 12 minus 2a is equal to 12 times square root of 2 minus 1, so we can substitute 12 minus 2a square in equation number 2 by 12 times square root of 2 minus 1 square. Okay, we'll do it now, and we'll get that according to equation number 2. Twelve minus b square equals to b square minus 12 plus 12 minus 2a square, and we will substitute 12 minus 2a square by 12 times square root of 2 minus 1 all squared. Okay, and we get that according to equation number 2, here 12 plus b square equals to 12 minus b square equals to 12 square plus b square minus 2 times 12 times b, that equals to b square, and here it is plus 12 square times square root of 2 minus 1 square. Okay, here we have b square on both sides of the equation, so b square will get cancelled. What is left from equation number 2 after we cancelled b square? What is left? It is actually 12 square minus 2 minus 12b is minus 24b, that equals to, here we have 12 square, and square root of 2 minus 1 square is square root of 2 squared, it is 2, plus 1 squared, it is 1, minus 2 times square root of 2 . So here we'll open the brackets and we'll get that 12, according to question number 2, 12 square minus 24b equals to 2 times 12 square plus 1 times 12 square So here we have 2 times 12 square after we open the brackets, plus 1 times 12 square, minus 2 times square root of 2 times 12 square. Here we have 12 square on both sides of the equation, so 12 square will get cancelled. And what is left after we cancel 12 square from the equation number 2? What is left? It is actually here, this side of the equation number 2, we have minus 24b, that equals to 12 square is 144, 144 times 2 is 288. And 12 square is 144, 144 times minus 2 is minus 188 times square root of 2. Here we divide the equation number 2 by 24. And we get that the coordinates of equation number 2 minus b is equal to 288 over 24 is 12, minus 288 over 24 is minus 12, and we have to multiply it also by square root of 2. Here we multiply equation number 2 by minus 1, and we get that according to equation number 2, b equals to 12 times square root of 2 minus 12. And we have already found out that a is equal to 12 minus 6 times square root of 2. And a plus b here a plus b is, we have minus 12 plus 12 is 0, and 12 times square root of 2 minus 6 times square root of 2 is 6 times square root of 2. So in conclusion, we found out that a plus b equals to 6 times square root of 2 units. In the next step, we will join points R and M together by a straight line. Here MR is the radius of this circle because of the fact that it starts from the center of this circle, that is to say from point M, and then at point R, that is a point on this circle itself. Therefore, MR is the radius of this circle, that is to say it equals to A. And we have the radius MR that is drawn to the point of tendency, that is to say it is drawn to point R, that is the point of tendency of tangent AC with this circle. And whenever we have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to that radius. In this case, the tangent AC will be perpendicular to the radius RM. Again, AC is perpendicular to RM, that is to say this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. In the next step, we will draw perpendicular on RM from point M. So this angle will be equal to 90 degrees according to our construction, and we will extend NS, that is the radius of the semicircle, by a straight line until it intersects with the perpendicular from point M. And we will define the intersection point of the extended NS and the perpendicular from point M as point X. So here we have quadrilateral RMSX, but before that we have NS is the radius of the semicircle that equals to B units, and NS as the radius of the semicircle must be a straight line, and when we extended the straight line NS by a straight line, we got NX. So NX is a result of the extensions of a straight line by straight line. Again, NX, line segment NX, is a result of the extension of a straight line by straight line. And when you extend the straight line by straight line, the result must be a straight line. So NX is a straight line. I'll repeat again. When you extend a straight line by a straight line, the result must be a straight line. So NX, that is the result of the extension of the straight line that is the result of the extension of the straight line NS by straight line, must be also a straight line. Again, NX, that is the result of the extension of the straight line NS by straight line, must be also a straight line, because whenever you extend the straight line by a straight line, the result must be a straight line. So NX is a straight line, and we have rule number 4. According to rule number 4, the sum of the angles on one side of a straight line is equal to 180 degrees. The sum of the angles on one side of a straight line is equal to 180 degrees. I will read rule number 1 again. According to rule number 1, the sum of the angles on one side of a straight line is equal to 180 degrees. So here we have the straight line NX. If we focus on the upper side of the straight line NS at point S, then the sum of the angles at point S must be equal to 180 degrees. Which angles we have at point S at the upper side of NX? We have here 90 degrees plus angle RSX. So 90 degrees plus the size of angle RSX, in total they must be equal to 180 degrees. Here we'll subtract 90 degrees from this equation, and we'll get that angle RSX is equal to 180 degrees minus 90 degrees, it is 90 degrees. So we found out that angle RSX is a right angle, it equals to 90 degrees. So actually in quadrilateral RMSX we have 3 right angles. In quadrilateral RMSX we have 3 right angles. The sum of 3 right angles is 270 degrees, plus the size of the fourth angle, that is actually angle MXS. In total, the sum of those four angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. We will subtract 270 degrees from this equation, and we will get that the size of angle MSX is equal to 360 degrees minus 270 degrees, it is 90 degrees. So we found out that angle MSX is the right angle, is equals to 90 degrees. Angle MX, it is actually angle MXS. So this angle is the right angle. So we actually found out that quadrilateral RMSX has four right angles, and any quadrilateral that has four right angles, it must be at least a rectangle. So we can write down that quadrilateral RMSX is at least a rectangle. I'll repeat again. Quadrilateral RMSX is at least a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, RM equals to SX. RM equals to SX. According to rule number 3, that the opposite sides of a rectangle are equal to each other. But we have already found out that RM equals to A. Rm equals to A, so from this equation A equals to Rm equals to Sx, we will derive that Sx is also equals to A. Sx is also equals to A, so we can write here that Sx is equals to A. Likewise, Mx must be also equal to Rs according to rule number 3. Mx must be equal to Rs according to rule number 3. Mx equals to Rs according to rule number 3, but Rs equals to A according to what we have already found out, and from this equation Mx equals to Rs, Mx equals to Rs equals to A, we will derive that Mx is also equals to A. Mx is also equals to A. So here, Mx is also equals to A. So here, because of the fact that angle MXN is a right angle, therefore triangle MXN is a right triangle. So here the green triangle MXN is a right triangle. So we can implement the Pythagoras theorem of the green right triangle MXN. According to the Pythagoras theorem, in the green right triangle MXN, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, mx squared plus nx squared must be equal to the square of the hypotenuse, that is mn squared. I will repeat again. In the right orange triangle MXN, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The square of the hypotenuse is mn squared. It must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to mx squared plus nx squared. We have already found out that mx is equal to a, so mx squared is a squared plus nx squared. Nx equals to a plus b, so nx squared is a plus b squared, and it equals to the square of the hypotenuse, that is mn squared. We have already found out that a is equal to 12 minus 6 times square root of 2 units, therefore a squared will be equal to 12 minus 6 times square root of 2 squared plus a plus b. We already found out that a plus b is equal to 6 times square root of 2, so a plus b squared will be equal to 6 times square root of 2 squared, and it equals to mn squared. So here we will open the brackets on this side of equation number 3. And we get that according to equation number 3, twelve minus 6 times square root of 2 squared is 12 squared plus 6 times square root of 2 squared is 72 minus 2 times 12 times 6 times square root of 2 plus 6 times square root of 2 squared is 72, that equals to mn squared. So here we have 12 squared is 144, 72 plus 72 is also 144, minus 2 times 6 is minus 12, minus 12 times 12 is minus 144 times square root of 2, that equals to mn squared. 144 plus 144 is 2 times 144, minus 144 times square root of 2 equals to mn squared. Here we take 144 as a common factor out of these two expressions, and we get, so 144 was taken as a common factor, was taken out as a common factor. So what if there is left from 2 times 144 after we took from it 144 is a common factor? What is left? It is actually 2. What is left from minus 144 times square root of 2 after we took from it 144 is a common factor? What is left? It is actually minus square root of 2, that equals to mn squared. Here we take a root out of this equation number 3, and we get that the square root of 144 is 12 times square root of 2 minus square root of 2. So in conclusion, we found out that mn is equal to either 12 times square root of 2 minus square root of 2 units, or in terms of numbers is equal to 9.18 units. I'll repeat again, mn, that is the distance between the center of the semicircle and the circle, it is equal to either 12 times square root of 2 minus 12 times square of square root of 2 minus square root of 2, square root of 12 times square root of 2 minus square root of 2, or in terms of numbers, it equals to 9.18 units. In the next step, I will summarize the lecture. Actually, we wanted to find out the length of line segment MN, we have here square ABCD, and inside this, one side of square ABCD equals to 12 units. Inside of this square we have a semicircle that its center is point M, and we have also circle that its point is at its point is at point M, and the distance between the centers is Mn, and we want to find out the length of Mn, that is actually the distance between the centers of the semicircle and the circle itself. So I defined the point of tendency of tangent AB with this circle as point P, and defined the point of tendency of tangent BC with this circle as point Q, and also we defined the point of tendency of tangent AC with this circle as point R, and we defined the point of tendency of tangent AC with this semicircle as point S, and we defined the touching point of the semicircle with side DC as point T, and then we defined PB as A. So if PB equals to A, then AP will be equal to 12 minus A. Then I presented to you rule number 1. According to rule number 1, the lengths of two tangents from a common external point to a circle are equal. So here, if we have this circle and the external point, point P, and from the external point P we draw two tangents to this circle, then the lengths of those two tangents will be equal to each other. In this case, PA will be equal to PB. We implemented rule number 2 in our drawing. We have the external point B. From the external point B we have tangent PB and tangent BQ. And according to rule number 1, BP equals to BQ, but according to our definition, BP equals to A. So from this equation, A equals to B, P equals to BQ, we derive that BQ is also equals to A. So BQ is also equals to A, because of the fact that BC minus BQ equals to QC, we will get that QC equals to BC, that is 12, BC that is 12 minus BQ that is A. So in conclusion, we found out that QC equals to 12 minus A. Okay? Then we focused at point A. From the external point A, we have two tangents to this circle. We have tangent AB and tangent AR. And according to rule number 1, the lengths of those two tangents are equal to each other, that is to say AP equals to AR according to rule number 1, but we have already found out that AP equals to 12 minus A, so from this equation 12 minus A equals to AP equals to AR, we will derive that AR is also equals to 12 minus A. So here AR is also equals to 12 minus A. Then we continue to focus on at point A. From the external point A, we have two tangents to the semicircle. The first tangent is tangent AD, the second tangent is tangent AS. And according to rule number 1, the lengths of those two tangents are equal to each other, that is to say AD equals to AS, but we know that AD equals to 12 units because it is the side, one side of square ABCD. So from this equation 12 equals to AD equals to AS, we will derive that AS is also equals to 12 units. So what is the length of RS? From the drawing you can see that RS equals to AS minus AR. RS equals to AS minus AR, AS equals to 12, AR equals to 12 minus A, so RS equals to 12 minus 12 plus A, because minus and minus is plus, so we found out that RS equals to A. Then we focused on the external point C. From the external point C we have two tangents to this circle. We have tangent CQ and tangent CR, and according to rule number 2, they are equal to each other. CQ is equal to CR, but we have already found out that CQ equals to 12 minus A, so from this equation 12 minus A equals to CQ equals to CR, we derive that CR is also equals to 12 minus A. Here, CR is equal to 12 minus A, and then we found out the value of line segment SC. SC will be equal to RC minus RS. Here SC equals to RC minus RS, RC equals to 12 minus A, RS equals to A, so in conclusion AC equals to 12 minus A, S equals to 12 minus A minus A, 12 minus A minus A is 12 minus 2A, so we found out that line segment AC equals to 12 minus 2A. Then we found out the length of diagonal AC. The length of diagonal AC equals to AR plus RC. AC equals to AR plus RC. So AC equals to AR, that is 12 minus A, plus RC, that is also 12 minus A. 12 minus A plus 12 minus A is 12 plus 12 is 24. Minus A minus A is minus 2A. So in conclusion, we found out that the length of diagonal AC equals to 24 minus 2A. Okay? Then I presented to you rule number 4, rule number 2. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So what is the meaning of rule number 2? The meaning of rule number 2 is that if we have this circle, the center of this circle is at this point, point O, and we have also tangent AB that is tangent to this circle at point M. Point M is the point of tendency of tangent AB with this circle. And we have the radius OM. You can see from the drawing that the radius OM, it is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency of tangent AB with this circle, and whenever we have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to that radius. Here, tangent AB will be perpendicular to radius MO. That is to say this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. We implemented rule number 2 in our drawing. Here we join points M and P together by a straight line. PM is the radius of this circle, and the radius PM on MP, it is drawn to the point of tendency, that is to say it is drawn for point B, that is the point of tendency of tangent AB with this circle, and whenever we have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to that radius. In this case, tangent AB will be perpendicular to the radius PM. AB perpendicular to PM, that is to say this angle equals 90 degrees, and this angle will be also equal to 90 degrees. And we know that the sum of the angles, all the angles inside the square are right angles, therefore triangle angle ABC in square ABCD must be equal to 90 degrees. We join points M and Q together by a straight line. MQ is the radius of this circle, and it is drawn to the point of tendency, that is to say it is drawn to point Q, that is the point of tendency of tangent BC with this circle, and whenever we have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to this radius. In this case, tangent BC will be perpendicular to the radius QM, that is to say this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. So in quadrilateral PBMQ we have 3 right angles. The sum of 3 right angles is 270 degrees, plus the size of the 4th angle, that is actually angle PMQ. In total they must be equal to 360 degrees. In quadrilateral PBMQ, the sum of 3 angles is 270 degrees, plus the size of the 4th angle, that is angle PMQ, must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtracted 270 degrees from this equation, and we got that angle PMQ equals to 360 degrees minus 270 degrees. 360 degrees minus 270 degrees, it is equal to 90 degrees. So we found out that the fourth angle, this angle equals to 90 degrees, therefore in quadrilateral PBMQ we have 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle. So quadrilateral PBMQ must be at least a rectangle, and we have also rule number 3, that the opposite sides of a rectangle are equal to each other. So the opposite sides of rectangle PB and Q are equal to each other. That is to say, PB equals to MQ, PB equals to MQ, but according to our definition, PB equals to A. So from this equation, A equals to PB equals to MQ, we will derive that MQ is also equals to A. Okay? And likewise, BQ equals to PM, BQ equals to PM, but we already found out that BQ equals to A, so from this equation A equals to BQ equals to PM, we will derive that PM is also equal to A. So we found out that quadrilateral PBMQ is not a rectangle but a square. Why? Because all of its sides are equal to each other. They are equal to A. Okay, then we focused on the right triangle, triangle ABC, and we implemented the Pythagoras theorem on the right triangle, triangle ABC. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the square of the perpendiculars, that is to say, AC squared equals to AB squared plus BC squared. AC is 24 minus 2A, so AC squared is 24 minus 2A squared, and it equals to AB squared, that is 12 squared, and BC squared, it is also 12 squared. So in conclusion, we found out that according to equation number 2, 24 minus 2A squared equals to 2 times 12 squared. 12 squared plus 12 squared is 2 times 12 squared. We took out of this equation and we got that 24 minus 2A equals to the square root of 2 times 12. Then we added to this equation 2A and we subtracted the square root of 2 times 12, and we got that 2A equals to 24 minus square root of 2 times 12, and we divided the equation number 2 by 2, and we got that A equals to 12 minus 6 times square root of 2 units. Again, the radius of the circle, that is A, equals to 12 minus 6 times square root of 2 units. Then we found out that we defined the radius of the semicircle as B, that is to say dn equals to B and T is also equals to B. So what is the length of TC? TC will be equal to DC minus dn minus NT. TC equals to DC minus dn minus NT. So TC equals to DC, that is 12 units, minus dn, that is B, minus dn, that is also B. In conclusion, we found out that TC equals to 12 minus 2B, so we can write down here that TC equals to 12 minus 2B. And then we joined points N and S together by a straight line. NS is the radius of this semicircle, that is to say it equals to B. And we have here the radius NS that is drawn to the point of tendency, that is to say it is drawn to point S, that is the point of tendency of tangent AC with this circle, and whenever we have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to this radius. In this case, the tangent AC will be perpendicular to radius SN. So AC is perpendicular to SN, that is to say this angle equals to 90 degrees and this angle will be also equal to 90 degrees. So the green triangle is the right triangle. We can implement the right triangle, we can implement the Pythagoras theorem on the green right triangle, triangle NSC. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. But we found out the value of NC, that is the hypotenuse of the green triangle. NC equals to NT plus TC. NC equals to NT plus TC. So NC equals to NT, that is B, plus TC, that is 12 minus 2B. So in conclusion, found out that NC equals, the hypotenuse NC equals to 12 minus B. Then we implemented the Pythagoras theorem on the right triangle NCS. According to the Pythagoras theorem, NC square equals to NS square plus SC square. NC square equals to NS square plus SC square. NC is 12 minus B, so NC square is 12 minus B square, and it equals to NS square is B square, plus SC square. SC square is 12 minus 2A square. And we found out the value of the expression of 12 minus 2A. 12 minus 2A equals 12 minus 2A, and A equals to 12 minus 6 times root of 2. So we got here, we have 12, and minus 2 times 12 is minus 24. And we have 2 times minus 2 times minus 6 is plus 12 times root of 2. So we have 12 times root of 2, and 12 minus 24 is minus 12. So in conclusion, we found out that 12 minus 2A is equal to 12 times root of 2 minus 12. We took 12 as a common factor from this expression, and we got that 12 minus 2A equals to 12, and inside the brackets we have square root of 2 minus 1. So we can substitute. So in conclusion, we found out that 12 minus 2A equals to 12 times square root of 2 minus 1, so we can substitute 12 minus 2A in equation number 2 by 12 times square root of 2 minus 1. We did it, and we got that according to equation number 2, 12 minus B square equals to B square, plus 12 minus 2A equals to 12 times square root of 2 minus 1 squared. Here we open the brackets. 12 minus B square equals to 12 square, plus B square minus 2 times 12 times B, and it equals to B square plus 12 square. Here we have 12 square times square root of 2 minus 1 square. According to the algebraic identity that xy to the power of m equals to x square, x to the power of m times y to the power of m. Okay, and here we have b square on both sides of the equation, so b square will get cancelled, and we have here 12 square, and minus 2 minus 12 is minus 24, so in this side of the equation we have 12 square minus 24b, that equals to 12 square. We open the brackets here. Square root of 2 minus 1 square equals to square root of 2 squared, that is 2, plus 1 squared, that is 1, minus 2 times square root of 2. So we have here 12 square minus 24b. We open the brackets here, and we have here 2 times 12 square, plus 1 times 12 square, minus 2 times square root of 2 times 12 square. We have 12 square on both sides of the equation, so 12 square will get cancelled, and we left only minus 24b, that equals to 12 square is 144, 144 times 2 is 288, and we have minus 12 square minus 2 is 144 minus 2, that is minus 288 times square root of 2. We divided the equation number 2 by 24, and we got that minus b equals to 12, minus square root of 2, minus b equals to 12, minus 12 times square root of 2. We multiplied the equation number 2 by minus 1, and we got that b equals to 12 times square root of 2 minus 12. We have already found out that a equals to 12 minus 6 times square root of 2, and a plus b, here you can see that a plus b equals to 6 times square root of 2 units. Then we added, we joined points R and S together, points M and R together by a straight line. Rm is the radius of this circle, that is to say it equals to A. And we have the radius MR, it is drawn to the point of tendency, that is to say it is drawn to point R, that is the point of tendency of tangent AC with this circle, and whenever we have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to this radius. In this case, the tangent AC will be perpendicular to the radius RM. That is to say, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. In the next step, from point M, we draw perpendicular on RM. So this angle equals to 90 degrees, and we extended NS, that is the radius of the semicircle, until it intersects with the perpendicular from point M, and we define the intersection point of the extended NS and the perpendicular from point M as X. Okay, so here, and we have rule number 4 that states that actually here NS is the radius of the semicircle, and as a radius it must be a straight line. When we extended the straight line NS by straight line, we got NX. And when you extend the straight line by straight line, the result must be a straight line. Therefore, NX is a straight line. And we have rule number 4 that states that the sum of the angles on one side of the straight line is equal to 180 degrees. So if we focus on the upper side of the straight line NS at point S, we have here 90 degrees plus the size of angle RSX. In total, they must be equal to 180 degrees according to rule number 4. We subtracted 90 degrees from this equation, and we got that angle RSX equals to 90 degrees. So this angle is the right angle, it equals to 90 degrees. So quadrilateral RMSX has 3 right angles, and the sum of 3 right angles is 270 degrees. So 270 degrees plus the size of the fourth angle, that is actually angle MXS, in total they must be equal to 360 degrees. In quadrilateral RMSX, the sum of 3 angles, that is 270 degrees plus the size of the fourth angle, that is actually angle MXS, in total they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. We subtracted 270 degrees from this equation, and we got that angle MXS is equal to 90 degrees. So this angle equals to 90 degrees, therefore in quadrilateral RMSX we have 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle. So quadrilateral RMSX is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, RM equals to SX according to rule number 3. But we have already found out that Rm equals to A, so from this equation A equals to Rm equals to Sx, we derive that Sx is also equals to A. Sx is also equals to A. Likewise, according to rule number 3, Mx must be equal to Rx. Mx must be equal to Rs according to rule number 3. But we have already found out that Rs equals to A. So from this equation Mx equals to Rs equals to A, we will derive that Mx is also equals to A. Here, Mx is also equals to A. So actually quadrilateral RMSX is not a rectangle but a square, because of the fact that all of its sides are equal to A. Okay? And because of the fact that angle MXN is a right angle, then triangle MXN, the orange triangle, is a right triangle. So we can implement the Pythagoras theorem on the orange right triangle, triangle MXN. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, mx squared plus nx squared equals to mn squared, that is the square of the hypotenuse. Mx equals to a, so mx squared is a squared. Nx equals to a plus b, so nx squared is a plus b squared, and it equals to the square of the hypotenuse, that is mn squared. A equals to 12 minus 6 times square root of 2, so a square will be equal to 12 minus 6 times square root of 2 square. A plus b equals to 6 times square root of 2, so a plus b square will be equal to 6 times square root of 2 square, and it equals to mn square. So here we open the bracket of this equation number 3, and we got that 12 minus 6 times square root of 2 square equals to 12 square, plus 6 times square root of 2 square, that is 72, minus 2 times 12 times 6 times square root of 2, plus 6 times square root of 2 square, that is 72, that equals to mn square. Here we have 12 square is 144, and 72 plus 72 is also 144, and we have also minus 2 times 6 is minus 12, minus 12 times minus 12 is minus 144, and we have also to multiply it by square root of 2, because here we have square root of 2. So in conclusion, we found out that 144 plus 144 minus 144 times square root of 2 equals to mn square. 144 plus 144 is 244, 2 times 144, and we have also minus 144 times square root of 2, that equals to mn square. Here we took 144 as a common factor out of these two expressions, and inside the brackets, what is left from 2 times 144, after we took from it 144 as a common factor, what is left, it is actually 2. And what is left from minus 144 times square root of 2, after we took from it 144 as a common factor, what is left from it is actually minus square root of 2. So here we took a root out of this equation number 3, and we got that the square root of 144 is 12, and we also have to put inside the root the expression of 2 minus square root of 2. So in conclusion, we found out that mn, that is the distance between the semicircle and the circle itself, the distance between the center of the semicircle and the circle itself equals to either 12 times square root of 2 minus square root of 2 units, or in terms of numbers, it equals to 9.18 units. I repeat again, mn, that is the distance between the center of the semicircle and the center of the circle, is equal to either 12 times square root of 2 minus square root of 2 units, or in terms of numbers, it equals to 9.18 units. Okay? Thank you very much.